as having a musical counterpart. Consequently, when a building was erected in which a number of these elements were combined, the structure was then likened to a musical chord, which was harmonic only when it fully satisfied the mathematical requirements of harmonic intervals. The realization of this analogy between sound and form led Gady to declare that architecture is crystallized music. In constructing their temples of initiation, the early priests frequently demonstrated their superior knowledge of the principles underlying the phenomena known as vibration. A considerable part of the mystery rituals consisted of invocations and intonements, for which purpose special sound chambers were constructed. A word whispered in one of these apartments was so intensified that the reverberations made the entire building sway and be filled with a deafening roar. The very wood and stone used in the erection of these sacred buildings eventually became so thoroughly permeated with the sound vibrations of the religious ceremonies that when struck they would reproduce the same tones, thus repeatedly impressed into their substances by the rituals. Every element in nature has its individual keynote. If these elements are combined in a composite structure, the result is a chord that, if sounded, will disintegrate the compound into its integral parts. Likewise, each individual has a keynote that, if sounded, will destroy him. The allegory of the walls of Jericho falling when the trumpets of Israel were sounded is undoubtedly intended to set forth the arcane significance of individual keynote or vibration. Pythagoras. The History of Philosophy c. 1660 by Thomas Stanley. From Egypt we move across the Mediterranean Sea to the Greek island of Samos, the birthplace of Pythagoras, whose ideas dominate most of the material in this course. We'll introduce Pythagoras and his secret society of the Pythagoreans. We'll look at the Pythagoreans' ideas about numbers, as a prelude to our next unit on number symbolism. Finally, we'll introduce a new idea that will be a recurring theme throughout this course, the musical ratios, which will reappear in discussions of the architecture of the Renaissance. Our main link between Egypt and Greece seems to be Thales c. 640550 BC, father of Greek mathematics, astronomy, and philosophy, and was one of the 7 sages of Greece. A rich merchant, his duties as a merchant took him to Egypt, and so became one of the main sources of Egyptian mathematical information in Greece. It was Thales advised his student to visit Egypt, and that student was Pythagoras. Pythagoras was born in Ionia on the island of Samos, and eventually settled in Prodon, a Dorian Greek colony in southern Italy, in 529 BC. There he lectured in philosophy and mathematics. He started an academy which gradually formed into a society or brotherhood called the Order of the Pythagoreans. Disciplines of the Pythagoreans included silence, music, incenses, physical and moral purifications, rigid cleanliness, a mild asceticism, utter loyalty, common possessions, secrecy, daily self-examinations, pure linen clothes. We see here the roots of later monastic orders. For badges and symbols, the Pythagoreans had the sacred tetractys and the star pentagram, both of which we'll talk about later. There were 3 degrees of membership. 1. Novices or politics. 2. Nomophytes, or first degree of initiation. 3. Mathematicians. The Pythagoreans relied on oral teaching, perhaps due to their pledge of secrecy, but their ideas were eventually committed to writing. Pythagoras' philosophy is known only through the work of his disciples, and it's impossible to know how much of the Pythagorean discoveries were made by Pythagoras himself. It was the tradition of later Pythagoreans to ascribe everything to the master himself. Pythagorean number symbolism. The Pythagoreans adored numbers. Aristotle, in his Metaphysica, sums up the Pythagoreans' attitude towards numbers. The Pythagoreans were the first to take up mathematics, and thought its principles were the principles of all things. Since, of these principles, numbers are the first, in numbers they seemed to see many resemblances to things that exist, more than left square bracket just right square bracket air, fire and earth and water, but things such as justice, soul, reason, opportunity. The Pythagoreans knew just the positive whole numbers. 0, negative numbers, and irrational numbers didn't exist in their system. Here are some Pythagorean ideas about numbers. Masculine and feminine numbers. Odd numbers were considered masculine, even numbers feminine, because they are weaker than the odd. When divided they have, unlike the odd, nothing in the center. Further, the odds are the master, because odd plus even always give odd. And 2 evens can never produce an odd, while 2 odds produce an even. Since the birth of a son was considered more fortunate than birth of a daughter, odd numbers became associated with good luck. The gods delight in odd numbers, wrote Virgil. 1 wanted. Point. The source of all numbers. Good, desirable, essential, indivisible. 2 tied. Line. Diversity, a loss of unity, the number of excess and rift. The first feminine number. Duality. 3 tried. Plane. By virtue of the tried, unity and diversity of which it is composed are restored to harmony. The first odd, masculine number. 4 tetrad. Solid. The first feminine square. Justice, steadfast and square. The number of the square, the elements, the seasons, ages of man, lunar phases, virtues. 5 pented. The masculine marriage number, uniting the first female number and the first male number by addition. The number of fingers or toes on each limb. The number of regular solids or polyhedra. Incorruptible, multiples of 5 and in 5. 6 the first feminine marriage number, uniting 2 and 3 by multiplication. The first perfect number, 1 equal to the sum of its deliquate parts, i.e., exact divisors or factors, except itself. Thus, 1 plus 2 plus 3 equals 6. The area of a 3-4-5 triangle. 7-heptad. The maiden goddess Hathene, the virgin number, because 7 alone has neither factors or product. Also, a circle cannot be divided into 7 parts by any known construction. 8 the first cube. 9 the first masculine square. Incorruptible, however often multiplied, reproduces itself. 10 decad. Number of fingers or toes. Contains all the numbers, because after 10 the numbers merely repeat themselves. The sum of the archetypal numbers 1 plus 2 plus 3 plus 4 equals 10. 27 the first masculine cube. 28 astrologically significant, as the lunar cycle. It's the second perfect number 1 plus 2 plus 4 plus 7 plus 14 equals 28. It's also the sum of the first 7 numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 equals 28. 35 sum of the first feminine and masculine cubes 8 plus 27. 36 product of the first square numbers 4x9. Sum of the first 3 cubes 1 plus 8 plus 27. Sum of the first 8 numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Figured numbers. The Pythagoreans represented numbers by patterns of dots, probably a result of arranging pebbles into patterns. The resulting figures have given us the present word figures. Thus 9 pebbles can be arranged into 3 rows with 3 pebbles per row, forming a square. Similarly, 10 pebbles can be arranged into 4 rows, containing 1, 2, 3, and 4 pebbles per row, forming a triangle. From these they derived relationships between numbers. For example, noting that a square number can be subdivided by a diagonal line into 2 triangular numbers, we can say that a square number is always the sum of 2 triangular numbers. Thus the square number 25 is the sum of the triangular number 10 and the triangular number 15. Sacred tetractys. One particular triangular number that they especially liked was the number 10. It was called a tetractys, meaning a set of 4 things, a word attributed to the Greek mathematician and astronomer Theon. C. 100 set. The Pythagoreans identified 10 such sets. 10 sets of 4 things. Numbers at 1, 2, 3, 4. Magnitudes at point, line, surface, solid. Elements fire and air, water, earth, fire. Figures at pyramid, octahedron, icosahedron, cube. Living things at seed growth in length, in breadth, in thickness. Societies, man at village, city, nation. Faculties, reason at knowledge, opinion, sensation. Seasons at spring, summer, autumn, winter. Ages of a person at infancy, youth, adulthood, old age. Parts of living things at body, 3 parts of the soul. Gnomons. Gnomon means carpenter's square in Greek. It's the name given to the upright stick on a sundial. For the Pythagoreans, the gnomons were the odd integers, the masculine numbers. Starting with the monad, a square number could be obtained by adding an L-shaped border, called a gnomon. Thus, the sum of the monad and any consecutive number of gnomons is a square number. 1 plus 3 equals 4. Also, 1 plus 3 plus 5 equals 9. Also, 1 plus 3 plus 5 plus 7 equals 16. And so on. The quadrivium. While speaking of groups of 4, we owe another one to the Pythagoreans, the division of mathematics into 4 groups, giving the famous quadrivium of knowledge, the 4 subjects needed for a bachelor's degree in the Middle Ages. Music of the spheres. Jubal and Pythagoras. So the Pythagoreans in their love of numbers built up this elaborate number lore, but it's maybe that the numbers that impressed them most were those found in the musical ratios. Let's start with this frontispiece from a 1492 book on music theory. The upper left frame shows Lubal or Jubal, from the Old Testament, father of all, who played the lyre and the pipe, and 6 guys whacking on an anvil with hammers numbered 4, 6, 8, 9, 12, 16. The frames in the upper right and lower left show Pythagoras hearing bells, plucking strings under different tensions, tapping glasses filled to different lengths with water, all marked 4, 6, 8, 9, 12, 16. In each frame he sounds the ones marked 8 and 16, an interval of 1 to call the octave, or diapason. In the lower right, he and Phileleos, another Pythagorean, blow pipes of lengths 8 and 16, again giving the octave, but Pythagoras holds pipes 9 and 12, giving the ratio 3-4, called the 4-4 diatessaron, while Phileleos holds 4 and 6, giving the ratio to 3, called the 5-4 diapent. There. 8, 16 or 1, 2 octave diapason. And 4, 6 or 2, 3/5 diapent. And 9, 12 or 3, 4/4 diatessaron. These were the only intervals considered harmonious by the Greeks. The Pythagoreans supposedly found them by experimenting with a single string with a movable bridge, and found these pleasant intervals could be expressed as the ratio of whole numbers.